This is an audio-visual presentation on mensuration. This is a continuation of what we did in mensuration 1. Now we consider cones. The figure we see here is called the cone. Now considering the cone, VO is the height of the cone. VB is the slant height of the cone. And OB is the base radius of the cone. Alpha is called the semi-vertical angle. Now, assuming we are asked to find the height h of the cone, how do we find the height? Now, when we consider the cone, VOB is a right angle triangle with a 90 degrees angle at O. So from the Pythagoras theorem, the square of the longest side, that is the slant height, and that is the hypotenuse of the triangle, is equal to the sum of the squares of the other two sides, that is VO and OB. So from the Pythagoras theorem, VB square, that is L square, is equal to VO square, that is H square, plus OB square, that is R square. So the slant height square, that is the hypotenuse square, is equal to the adjacent square, that is adjacent to the angle alpha, plus the square of the base radius. So if L square equals H square plus R square, take note that we are solving for the height of the cone. So we make H the subject. Now plus R square on the right hand side of the equation becomes minus R square on the left hand side, and this is equal to H square. So we have L square minus R square equals H square, and this can also be written as H square equals L square minus R square. That is, the right hand side becomes the left hand side, and the left hand side becomes the right hand side. It is the same equation. We have not changed anything. Now if H square is equal to L square minus R square, take note that we are searching for the height of the cone, not the square of the height. That means that we need to take the square root of both sides to eliminate the exponent 2. And so when we take the square root of the left hand side, that is H square, we have H. And when we take the square root of the right hand side, that is L square minus R square, we have the root of L square minus R square. So if the slant height is known and the base radius is known, then it means that we can find the height of the cone. So that is how we find the height of the cone. Now, let's look at this example. Given the cone as shown, VB is the slant height, and it has been given to be 5 centimeters. The base radius, R, is equal to 3 centimeters. But the H, that is the height of the cone, is not given. Now, we are solving for H. We said that triangle VOB is a right angle triangle with a 90 degrees angle at O. And so from the Pythagoras theorem, the square of the longest side is equal to the sum of the squares of the other two sides. I repeat, from the Pythagoras theorem, the square of the longest side, that is the hypotenuse of the triangle, is equal to the sum of the squares of the other two sides, that is VO and OB. So it means that from the Pythagoras theorem, we have L square is equal to H square plus R square. So L square is equal to H square plus R square. Don't forget that L is equal to 5 and R is equal to 3, and we are supposed to find the height. So by substitution, instead of L square, we have 5 square because L is equal to 5. Now we have plus R square on the right hand side, and because we are solving for H, plus R square on the right hand side is moved to the left hand side and it becomes minus 3 squared because r is equal to 3. So we have 5 squared minus 3 squared is equal to h squared. Now this can also be written as h squared on the left hand side is equal to 5 squared minus 3 squared. Take note that we are solving for the height, so we need to take the square root of both sides. When we take the square root of h squared, we are left with h, and we also take the square root of the right hand side. So taking the square root of the right hand side, we have the square root of 5 squared minus 3 squared, and h is equal to the square root of 5 squared is 25 minus 3 squared is 9. Now 25 minus 9 is equal to 16. It means that h is equal to the square root of 16. And when you take the square root of 16, the answer is 4. That means that the height of the cone is equal to 4. That is the height of the cone is equal to 4. The height of the cone is equal to 4. So h is equal to 4. Now, still considering the cone, we said that the angle alpha is called the semi-vertical angle. VO, that is h, is the height of the cone. VB, that is L, is the slant height of the cone. And OB, that is R, is the base radius of the cone. Now the angle alpha equals question mark. This means we are searching for the angle alpha. Now, we consider the triangle VOB, which is a right angle triangle with the 90 degrees angle at O. Considering the angle alpha, R is opposite to the angle alpha. I repeat, the side OB, that is equal to R, is opposite to the angle alpha. And VO, that is H, is adjacent to the angle alpha. VB, that is L, is the hypotenuse of the triangle. Now, assuming we were given the base radius, that is R, the side opposite to the angle, and we are also given the adjacent, that is H, the height of the cone. How do we find the semi-vertical angle, that is alpha? Now, we use the ratio tan alpha because tan is equal to opposite over adjacent. So opposite to the angle alpha is R and the adjacent is H. So if tan alpha is opposite over adjacent, then it's equal to R over H because the opposite is the radius. The opposite is the radius and the adjacent is the height, that is H. So tan alpha is equal to R over H. Now we are solving for alpha, that is the semi-vertical angle, not tan alpha. This means that we need to take the tan inverse of both sides. And when we take the tan inverse of the left hand side, we are left with alpha. And this is equal to, when we take the tan inverse of the right hand side, we have tan inverse of R over H. Now if the radius is given and the height is also known, we can find the angle alpha by taking the tan inverse of the answer, by taking the tan inverse of R over H. So that is how we calculate for the angle alpha. That is the semi-vertical angle. Now, let's consider this example. Considering the cone as shown, we are given the height of the cone to be 4 centimeters. We have the slant height L of the cone, that is the hypotenuse of the triangle VOB, to be 5 centimeters. And we are given the base radius to be 3 centimeters. Now, how do we find the angle alpha? Using the ratio tan alpha, tan is opposite over adjacent. So tan alpha will be equal to, when we consider the angle alpha, we can see that the side R equals 3 centimeters is opposite to the angle alpha, and the side VO, that is H, equals 4 centimeters, is adjacent. So tan alpha is equal to 3 over 4. That is opposite to the angle alpha divided by the adjacent to the angle alpha. So tan alpha is equal to 3 over 4. Now, because we are solving for alpha, we need to take the tan inverse of both sides. And when we take the tan inverse of tan alpha, we are left with alpha. And this is equal to, when we take the tan inverse of the right hand side, we have tan inverse of 3/4. And when we take the tan inverse of 3/4, we have alpha to be equal to 36.86, which is approximately equal to 37 degrees. That means that the semi-vertical angle alpha is equal to 37 degrees. Take note, because when you consider the right angle triangle VOB, you realize that all the three sides of the triangle is given. We have VO, that's the height of the cone. We have OB, that's the base radius of the cone. And we have VB, that's the slant height of the cone. Because all the three sides of the triangle is known, it means we can use any of the ratios, either sine, the tan, or the cos, and we'll be able to find the angle alpha, as we've done here. Now we proceed. Now we are looking at cones developed from sectors of a circle. Cones that are developed from the sectors of a circle. Now let's consider the circle as shown. This is a circle as shown. Now we have a sector OAB. OB is equal to R, that is the radius of the circle. The shaded portion is the minor sector. Take note that we have two sectors. In this case, that is the minor sector and the major sector. OAB is the minor sector and OAB is the major sector. So the shaded portion is the minor sector and the unshaded portion is the major sector. Now, in this case, we've taken the minor sector from the circle. So we can now see the two sectors very well. We have the minor sector and we have the major sector. So OAB is the minor sector and OAB is also a sector, that is the major sector. Take note that OB is the radius of the circle. Now there is something you have to take note about the cones that are developed from the sectors of a circle. Now let me show you this. We have two sectors, that is the minor sector and the major sector. Each of these sectors can be used to form a cone. How do we form the cone? Now let's consider the minor sector first. OA and OB are straight edges. When we try to bring OA and OB together, we formed a cone, and that cone is formed from the minor sector. Similarly, when we consider the major sector and we try to bring edge OA and OB together, we also form a cone, but that is a cone developed from the major sector. Now there is one thing you have to take note here, that when cones are developed from a sector, the length of the arc of the sector is equal to the radius of the circle. That is the length, the slant height. I repeat, take note of this. L is equal to R. The L is the slant height of the cone you are forming or you are formed. And R is the radius of the circle from which the cone was formed. Now I go over this. This is what I want you to take note about cones that are developed from sectors of a circle. L equals R, where L is the slant height of the cone formed, and R is the radius of the circle from which the cone was formed. The radius of the circle, that gives us the two sectors. So L is equal to R. Now take note that the cone formed is a hollow cone. Any cone that is formed from a sector of a circle is a hollow cone. What do you mean by a hollow cone? A hollow cone is a cone without a base. A hollow cone is a cone without a base, as can be shown on the diagram. So any cone that is formed from a sector of a circle, take note, that cone is a hollow cone. That cone is a hollow cone. Now, let's take note of this. When you form a cone from a sector of a circle, either the minor sector or the major sector, take note of this. the length of the arc AB is equal to the circumference of the circular base. Now let me try to explain to you to understand. Now we have two sectors. We have the minor sector and we have the major sector. Considering the minor sector, AB is an arc, and that arc is a minor arc because this is the minor sector. The same AB from the major sector is an arc, but that is the length of an arc of the major sector. So AB here is a minor arc, and AB from here is the major arc because we have the minor sector and the major sector. Now what we are saying is the length of the arc AB, assuming you've used the major sector in forming your cone, the length of the arc, that is the distance from A to B, the length of the arc AB, assuming you are forming the cone with the major sector, the length of the arc AB is always equal to the circumference of the circular base. That is the circumference of the circular base. The circumference of the circular base. Now, assuming you form the cone from the minor sector, in this case, the length of the arc will be this. This is the length of the arc AB. This is the length of the arc AB. And we are saying that the length of the arc AB is equal to the circumference of the circular base. The circumference of the circular base. Now, we said that the length of the arc AB is equal to the length of the circumference, or the circumference of the circular base. The length of the arc AB equals the circumference of the circular base. Now, how do we find the length of an arc? It's theta divided by 360 times 2 pi r. Theta divided by 360 times 2 pi r, where r is the radius of the circle from which the sector was formed. And this is equal to 2 pi r, where 2 pi r is the formula for finding the circumference of a circle. Now, we multiply theta by 2 pi r and we divide the results by 360. So theta times 2 pi r will give us 2 pi r theta divided by 360. And this is equal to 2 pi r. Here we cross multiply. So 360 times 2 pi r is equal to 2 pi r theta, because the denominator of the 2 pi r is 1. 2 pi r divided by 1 is the same thing. So that 1 multiplies the 2 pi r theta, and that is how come we have 2 pi r theta. So we have 360 times 2 pi r is equal to 2 pi r theta. We are solving for the base radius, that is r, which means that we have to divide the left hand side by 360 times 2 pi. And we also divide the right hand side by 360 times 2 pi. So we have r left on the left hand side is equal to 2 pi r theta, 2 pi r theta divided by 360 times 2 pi. And take note that 2 pi will cancel 2 pi. And so we are left with r theta at the top divided by 360 at the down. So r, which is the base radius of the cone, is calculated using the relation r theta divided by 360. And that is the proof of where the formula r theta divided by 360 is coming from. So the base radius of the cone is calculated using the relation r theta divided by 360. Now let's consider this example. The sector of angle 120 degrees is cut removed. The remaining portion forms the cone. Calculate A, the base radius, B, the semi-vertical angle, C, the height of the cone, and take pi to be equal to 3.142. Now let's analyze the question. The question says the sector of angle 120 degrees is cut removed. So when you look at the circle, the center, you realize we have two angles. We have 120 degrees angle and we have 240 degrees angle. Take note, that when we add the 240 degrees to the 120 degrees, we have 360 degrees. That is one complete revolution. The angle at the center, the total angle at the center of a circle, is equal to 360 degrees. That is one complete revolution. Now from the question, the sector of angle 120 degrees is cut removed. So if 120 degrees is to be cut out, it means that the remaining angle at the center will be 240 degrees. Now we are given the radius of the circle to be 14 centimeters, as can be seen on the diagram. Now let's go back to the question. After the sector of angle 120 degrees is cut removed, the question goes on to say that the remaining portion forms the cone. So what is the remaining portion? The remaining portion is the portion with the 240 degrees angle. That is the major sector. The question says that the remaining portion, and the remaining portion is the portion left after the 120 degrees has been cut removed. It means that the cone that we are going to form is the cone with the cone from the sector of angle 240 degrees. Now we are asked to calculate the base radius, the semi-vertical angle, and the height of the cone, giving the constant pi to be 3.142. Now let's look at the solution. So we can see that the 120 degrees angle has been cut out. The 120 degrees angle, that is the minor sector, has been cut out, and we are left with the remaining portion. That is the portion with the 240 degrees angle. We are given the radius of the circle to be 14. Now this remaining portion is folded to form the cone. How do we form the cone? We try to bring these straight edges together and the cone is formed. Take note that we said that any cone that is formed from the sector of a circle is a hollow cone. It's a cone without a base. And so since we are forming this cone from this sector, from a sector, it means that this cone that we have formed is a hollow cone. It's a cone without a base. Now, at the beginning, we said that the radius of the circle from which the sector was formed, out of which we had our cone, is the same as the slant height of the cone formed. So the radius of the circle, that is 14 centimeters, is the same as the slant height, that is OB, 14 centimeters. Don't forget that R is our base radius. R is the base radius. Now, how do we find the base radius? How do we find the base radius? Angle theta is equal to 240 degrees. That's the angle of the sector which we used in forming the cone. So the theta we are going to use is 240 degrees. Now from the relation, the base radius R is equal to R theta divided by 360. R is the same as the slant height of the cone, that is 14. R, being the radius of the circle, is the same as the slant height of the cone, and that is 14. Theta is the angle 240 degrees. And so R will be equal to 14 times 240 divided by 360. And 14 times 240 divided by 360, R is equal to 9.33 centimeters. That means that the base radius of the cone equals 9.33 centimeters. Now, let's proceed. How do we find the semi-vertical angle? Take note that the slant height is known, and that is 14 centimeters. The base radius has just been calculated, and we had 9.33 centimeters. So when we consider the right angle triangle VOB, we can see that we have two sides. That is the slant height, that is the hypotenuse, the longer side, and the base radius. Now when we consider the angle alpha, we can see that the side OB, that is the base radius, is opposite to the angle alpha, and the hypotenuse, that is 14 centimeters, is the hypotenuse to the angle alpha. So we can see that considering the right angle triangle VOB, we have the opposite and we have the hypotenuse. That means that we use the ratio sine, because sine is equal to opposite over hypotenuse. So the ratio you are going to use is dependent on the size that you are given. It's dependent on the size of the right angle triangle given. Now sine alpha is equal to opposite over hypotenuse, and the opposite to the angle alpha is 9.33 and the hypotenuse is 14. So sine alpha is equal to 9.33 divided by 14. Now sine alpha is equal to 0.6664. That is when we divide 9.33 by 14, the answer is 0.6664. So alpha will be equal to the sine inverse of 0.6664. And when we take the sine inverse of 0.6664, the answer is 41.79 degrees. So the semi-vertical angle alpha is equal to 41.79 degrees. Now let's proceed. How do we find the height of the cone? Let's consider the right angle triangle VOB with a 90 degrees angle at O. This is a right angle triangle. That means we can use the Pythagoras theorem to solve for the height, because we already know two sides of the triangle. That is side OB, that is 9.33, and the side VB, the hypotenuse, that is 14 centimeters. Now take note that from the Pythagoras theorem, considering a right angle triangle, in this case our right angle triangle is VOB. From the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides, that is the h and the r. So 14 square is equal to h square plus r square. Now we have 14 square is equal to h square plus, take note that the r, that is the base radius, is 9.33. So we have plus 9.33 square. Don't forget that we are calculating for the height of the cone. So we have to make h the subject. That means that our plus 9.33 square on the right hand side becomes minus 9.33 square on the left hand side. Now 14 square is equal to 196 minus 9.33 square will be equal to 87.0489, and this is equal to h square. Now when we subtract 87.0489 from 196, the result is 108.951, and this is equal to h square. Take note that we are solving for the height, not the square of the height. So we have to take the square root of both sides. When we take the square root of h square, we are left with h. And when we take the square root of 108.951, we have the square root of 108.951. And when we take the square root of 108.951, the answer is 10.44 centimeters. H is equal to 10.44 centimeters. So that is our height of the cone. Now from the question, we have to find the volume. The volume of the cone. And volume of a cone is given by 1/3 times the base area times the height. So V equals 1/3 times pi r square. Why pi r square? Because pi r square is the formula for the area of a circle, the formula for calculating the area of a circle. Why are we talking about a circle here? The base area, the base of the cone is circular, so it's a circle. So if you are searching for the base area, then it means that we are searching for area of a circle, and the formula for finding the area is pi r square times, don't forget we have our height, so times h. Now pi is a constant that has been given to be 3.142. So the volume V is equal to 1/3 times pi is now 3.142 times the square of the radius, that is 9.33 square, times the height, and the height is 10.44. Now when we multiply 1/3 by 3.142 by 9.33 square by 10.44, we have the volume is equal to 951.8 centimeters cube. So the volume of the cone V equals 951.8 centimeters cube. Now let's consider the pyramid. Now we consider the pyramid. This is a pyramid as shown. VO is the height of the pyramid. That is VO is the height of the pyramid. VBC is a slant face. VBC is a slant face. VAB is also a slant face. That is VAB is another slant face. VAD is a slant face. VAD is also a slant face. VDC is a slant face. So we have VDC is also a slant face. Now VE, that is VE, is the slant height of the pyramid. Take note that the height of the pyramid H is not equal to the slant height of the pyramid. Now, to understand the slant faces, this is what we are saying. VBC is one slant face. VAB is another slant face. VAD is also a slant face, and VDC is another slant face. Now, VO is the height of the pyramid, and VE is the slant height of the pyramid. Now, let's proceed. The total surface area of a pyramid is equal to the area of net. The total surface area of a pyramid is equal to the area of net. So total surface area is equal to area of polygon base. That is area of the base plus 4 times area of the triangular face. Times 4 times area of the triangular face. Why are we multiplying by 4? Because the triangular faces are 4. So if we calculate the area of one triangular face, we multiply the answer by 4. Then we add it to area of the polygon base and we have our answer. Now, volume of a pyramid is 1/3 times the area of the base times the height. 1/3 times the area of the base times the height. Now, let's consider the pyramid. First, we are going to look at how we can calculate the height of the pyramid. We are going to look at how we can calculate the height of the pyramid. So we know that VO is the height of the pyramid. Now, in calculating the height of the pyramid, we are going to consider a triangle that is including the height. And the triangle we are considering is triangle VAO. That is triangle VAO. Take note that the distance VA has been given to be D. And so we have VA to be D. VO is the height of the pyramid. And AO, the distance from A to O, is half the distance from A to C. That means that if you know the distance from A to C and we divide the distance by 2, we have the distance from A to O. Now, considering right angle triangle VAO, VA is D, VO is the height. That is what we are searching for. And AO is half AC. So let's look at how best we can find AC, so that when we get AC, we can take half of it, and that will give us the distance from A to O. Now, we are going to consider another triangle in which AC is one of its sides, and that is triangle ABC, where the distance AB is A and the distance from B to C is B. So triangle ABC. The distance from A to B is A and the distance from B to C is B. So now, what we are going to do is to calculate for the distance from A to C. And because there is a right angle triangle, from the Pythagoras theorem, AC square, that is AC square, is equal to AB square, that is AB square, plus BC square, and that is BC square. So AC square is equal to, take note that AB is A, so we have A square, plus BC is B, so we have B square. Now, if AC square is equal to A square plus B square, how do we find AC? We have to take the square root of both sides, And so that is how come we have the square root of AC square is equal to the square root of A square plus B square. Now taking the square root of AC square, we have AC on the left hand side is equal to the square root of A square plus B square. Now that we know AC, we can take half of AC and the distance from A to O is known. Now let's consider triangle VAO now that we have the distance AC. Now considering triangle VAO is a right angle triangle with a 90 degrees angle at O. So from the Pythagoras theorem, the square of the longest side, that is D square, is equal to the sum of the squares of the other two sides, that is H square plus the distance AO square. So D square is equal to H square plus the distance from A to O is half AC. So we square. Now, because we are solving for H, plus half AC square is moved to the left hand side of the equation and it becomes minus half. Take note that after calculating the AC, we had the square root of A square plus B square. So by substitution, instead of writing AC, we write the square root of A square plus B square, and this is equal to H square. So because we are solving for H, we take the square root of both sides, and taking the square root of the right hand side, we are left with H. And when we take the square root of the left hand side, we have the square root of D square minus half the square root of A square plus B square. So if D, A, and B are all known, it means that you'll be able to find the height of the pyramid. It means that you'll be able to find the height of the pyramid. Now let's look at the angle between face VBC and the base. Where do you have the face VBC? This is the face VBC, VBC, and the base. And so that is the base. Now, the slant height VE is representing the whole surface, the whole face VBC. And OE is representing the base. So if you are searching for the angle between the face VBC and the base, the angle is the theta as shown. And now, to be able to calculate for the angle theta, we consider the right angle triangle VOE. And so we have the triangle VOE. Now theta is the angle between the face VBC and the base, because VE is representing the whole face VBC and OE is also representing the base. So the angle theta is what we are calculating for. Take note that VO is the height of the pyramid and OE is half A. What do you mean by that? The distance from A to B is A. Since O is the center of the base, it means that the distance from O to E is half the distance AB. And so OE is half A. Now, when we consider the right angle triangle VOE, we can see that H is opposite to the angle theta and half A is adjacent. So we use the ratio tan theta. And tan theta is equal to opposite, that is H, divided by the adjacent, that is half A. So if you want to find theta, we take tan inverse of both sides. And so we have theta left on the left hand side is equal to tan inverse of H over half A. So if the height is known and the A is also known, it means that we can find the angle between the face VBC and the base. That is the angle theta. So this is what we are talking about. This is the angle between the face VBC and the base. Now, we look at angle between faces VBC and VAD. Now, we have two faces. One of the faces is VBC, that is VBC. And the other face is VAD, that is VAD. Now, VE is representing the face VBC and VF is representing the face VAD. So if you are supposed to find the angle between these two faces, then the angle is the angle alpha as shown in the diagram. Now, to calculate for the angle alpha, we have to consider the triangle. And that triangle is triangle VFE. So we have triangle VFE. Now, this is the alpha. That is the angle we are calculating for. Now, when you draw a line from the vertex V to the center O, VO is the height of the pyramid. Take note that the distance from F to E is the same distance from A to B. So if the distance from A to B is A, then it means that the distance from F to E is also A. So if O is the center of the base, then the distance from F to O will be half A, and the distance from O to E will also be half A, since the whole distance is A. Now, considering triangle VOE, beta is an angle. But don't forget that we are searching for the angle alpha, but we need to calculate beta first. After calculating the angle beta, we multiply the results by 2, and our alpha is out. Now let's proceed. Considering the triangle VFE, if you want to calculate for the angle alpha, we can see that half A is opposite to the angle beta. I repeat, if you want to calculate for the angle beta, we can see that half A is opposite to the angle beta, and H is adjacent. That means we can use the ratio tan beta. So tan beta equals opposite, that is half A, divided by the adjacent, that is the H. So beta will be the tan inverse of the right hand side. Beta will be the tan inverse of half A over H. Now, after beta has been calculated, we now multiply the angle beta by 2, and our alpha is out, because beta twice beta is equal to alpha. So if you calculate for beta, you only multiply the angle beta by 2, and your alpha is out. Now let's consider this example. A pyramid with vertex O stands on a square base ABCD. So the vertex is O, the base is a square. So we have square ABCD, and OA, that's the distance from O to A, equals OC equals OD equals AB equals 5 centimeters. Now, let's look at something here before we go to the solution. The base is a square. So we have square base ABCD. Now, AB has been given to be 5 centimeters. That means that the distance from B to C is 5. The distance from C to D is also 5 when we form the square base. Now, we are calculating for A, the height of the pyramid, and B, the volume of the pyramid. A, the height of the pyramid, and B, the volume of the pyramid. Now C, the angle between plane OAB and the base. D, the total surface area of the pyramid. E, the angle between faces OAB and OCD. Now, from the question, this is our pyramid. We have the square base ABCD. So if AB is 5, it means BC is 5, CD is 5, and DA is also 5. And we are also told that the distance from O to all the vertices is 5. So OA is 5 centimeters, OC is 5 centimeters, OD is 5 centimeters. So it means that OB will also be 5 centimeters. Now, how do we find the height of the pyramid? How do we find the height of the pyramid? So we have to consider first the triangle OAV. So we have triangle OAV. OA is 5 centimeters. AV is half the distance AC. And OV is the height. That is what we are calculating for. So if you know the distance AC, the distance from A to C, we can divide the results by 2, the distance by 2, and you have the distance from A to V. How do we calculate for the distance AC? It means we have to consider another triangle. And we consider triangle ABC. So considering triangle ABC, we know that AB is 5 centimeters and BC is also 5 centimeters. Now let's find AC. After finding AC, we divide it by 2 and we know the distance from A to V. So we proceed. Now triangle ABC is a right angle triangle with a 90 degrees angle at B. So from the Pythagoras theorem, AC square will be equal to AB square plus BC square. Now, let's first consider the triangle with the height as one of its sides. We have triangle OAV. OA is 5 centimeters. OV is H and AV is half AC. Now, it's a right angle triangle. So from the Pythagoras theorem, AO square is equal to AV square plus VO square. Now AO is 5, so we have 5 square equals AV square plus H square because VO is H. Now we are solving for H. So AV square on the right hand side becomes minus AV square on the left hand side. Now because the AV is not known, it means we cannot find the height. So AV is question mark in this case. Now we consider the triangle ABC. And why are we considering this triangle? Because we want the distance from A to C. So that after getting the distance, we divide it by 2 and that will give us the distance from A to V. So from the Pythagoras theorem, AC square is equal to AB square plus BC square. That is AC square is equal to AB square plus BC square. Now AC square is equal to AB is 5 centimeters and BC is also 5 centimeters. So we have 5 square plus 5 square. And so AC square is equal to 25 plus 25. And 25 plus 25 is equal to 50. So AC square is equal to 50. Now, because we are solving for AC, we take the square root of both sides. And when we take the square root of AC square, you have AC. When we take the square root of 50, you have the root of 50. And the answer is 7.07 centimeters. That means that the distance from A to C is now 7.07 centimeters. And therefore, if you want the distance from A to V, it's a matter of dividing the results by 2. That is half of 7.07. And the answer is 3.535. 3.535. So now that we know the distance from A to V, together with the hypotenuse, we can find the height. We can find the height. Now, we know that AV is 3.535. As we saw previously, and the distance from O to A is 5 centimeters, and we are searching for the heights. Now AV is 3.535. So from the Pythagoras theorem, 5 square is equal to AV square plus H square. So 5 square is equal to AV square plus H square. And therefore we have 25 minus AV square is equal to H square. Now 25 minus AV has been calculated to be 3.353. So we have 3.535 square is equal to H square. Now when we take note that 3.53 square is equal to 12.50. So when you subtract 12.50 from 25, you are left with 12.5. And so we have 12.5 is equal to H square on the right hand side. Now we are solving for H, so we take the square root of both sides. So we take the square root of 12.5, and that will give us 3.54. When we take the square root of H square, we are left with H. That means that finally we have H is equal to 3.54 centimeters. So the height of the pyramid is 3.54 centimeters. Now the volume of the pyramid. Volume of a pyramid is 1/3 times the base area times the height. How do you find the base area? We have to know the base first, and the base is a square from the question. So all the sides are equal. We have 5, 5, 5, 5. base area. How do you find the area of a square? It's 5 times 5. That is length times length. So 5 times 5. So it's 25 centimeters square. Now the volume is equal to 1 over 3 times the base area. And the base area is now 25 times the height of the pyramid. And after our calculation, from our calculation, we are 3.54. So 1 over 3 times 25 times 3.54 will give us volume to be equal to 29.5 centimeters cube. Now we look at the angle between plane OAB and the base. The angle between plane OAB and the base. And the plane OAB and the base, the angle is theta. Take note, OAB is a slant face. It means that OE is a slant height. OE is a slant height. So if you want to find the angle between the plane OAB, the slant height OE represents the surface OAB and EV represents the base. So the angle between OE and EV is theta, and that is the angle between plane OAB and the base. Now how do we find the angle? We have to consider the triangle OEV, where V is the center of the base. So we have OEV, and we are calculating for the angle theta. Now, the distance from B to C is 5 centimeters. The distance from E to V is half the distance from B to C. That means that EV is half of 5, and that is 2.5 centimeters. OE, that is OE, is the height of the pyramid, and from our calculation, we had 3.54 centimeters. So how do we find the angle theta? When we consider the angle theta, the triangle in general, the triangle OEV, we are given two sides. But considering the angle theta, 3.54 is opposite to the angle theta. That means we are given the opposite side. And 2.5 is adjacent to the angle theta. That means we also know the adjacent. So we use the ratio opposite over adjacent. That is tan theta. So tan theta is equal to opposite. That is 3.54 divided by adjacent. That is 2.5. And the answer is 1.416. Now theta is equal to tan inverse of 1.416. And the answer is 54.77 degrees. So the angle between plane OAB and the base is 54.77 degrees. That is the angle between plane OAB and the base. That's the angle theta is equal to 54.77 degrees. Now let's look at the area of the pyramid. We said that the area of the pyramid is equal to the area of the net, and this is the net of the pyramid. That is when we carefully dismantle the pyramid. This is the shape we are going to form, and we call this the net of the pyramid. We call this the net of the pyramid. ABCD is the square base. ODC is one triangular face. OCB is one triangular face. OAB is another triangular face. And ODA is also another triangular face. And all the triangles are the same. All the triangles are the same because the base is a square. All the sides are equal. Let's look at how we can find the area of the pyramid. Now, these are the distances given. The distances from O to D is 5, O to C is 5, C to O is 5, O to B is 5, the distance from B to O is 5, the distance from O to A is 5, the distance from O to A is 5, the distance from O to D is also 5, because O is the vertex, the O is the vertex of the pyramid. Now, if you are finding the area of the pyramid, it is the area of the base, and the base is a square, and that is what we have here, plus 4 times the area of the triangle. Because the triangles are the same, we take only one into consideration. After finding the area, you multiply our answer by 4, then we add it to the area of the base, and that will give us the area of the pyramid. Now, considering the square base, the area of a square is length times length. That is 5 times 5, and the answer is 25 centimeters square. Now, area of the triangle. Area of the triangle. Area of a triangle is calculated using half times the base times the height. Half times the base times the height. So area is equal to half times the base. Now the base is AB. That's the distance from A to B. The distance from A to B is the base. That is 5 centimeters. So we have half times 5 times h, where h is the height of the pyramid. Where h is the height of the pyramid. So if the height is known, we now multiply by half times 5, and that will give us the area. But because the height is not known, it means we have to calculate for the height. And to calculate for the height, we have to draw a line from the vertex to the center of the line AB. And this is our height. So we consider part of the triangle. That is triangle either OAJ or OJB. We still get the same thing. Now, considering triangle OAJ. Considering triangle OAJ. From the Pythagoras theorem, 5 square will be equal to 2.5 square plus h square. So if 5 square is equal to 2.5 square plus h square, then how do we find h? 2.5 square on the right hand side becomes minus 2.5 square on the left hand side. 5 square is 25 minus 2.5 square is 6.25, and this is equal to h square. Now when we subtract 6.25 from 25, the result is 18.75, and this is equal to h square. Now we are solving for h, so we take the square root of both sides, and so we have h is equal to the square root of 18.75, and the answer is 4.33. Now the height has been calculated to be 4.33. That means that we can now find the area, because area of the triangle is half the base times the height. Area of the triangle is half times the base times the height. So we have half times the base, the distance from A to B, that is 5, times the height. From our calculation, we have the height to be 4.33. So half times 5 times 4.33 is equal to 10.825 centimeters cube. So the area of the triangular face equals 10.825 centimeters cube. Now area of the pyramid is equal to the area of the base plus 4 times area of the triangle. Now when we calculated the area of the square base, we have 25 centimeters square. Now plus 4 times the area of one triangular face give us 10.825. So we multiply the answer by 4, and we have 43.3. Then we add it to 25 centimeters square, and the result is 68.3 centimeters square. So the area is equal to 68.3 centimeters square. That is the area of the pyramid. Now let's look at the angle between faces OAB and OCD. The angle between faces OAB and OCD. Now, where are the faces? We have face OAB, and the line OE is representing that face. And we also have face OCD, that is face OCD, and the line OE is also representing the face. So if you are finding the angle between these two faces, the angle is theta as shown. The angle is theta as shown. Now, let's consider the triangle OEF. Triangle OEF. That is the triangle we have here. We have triangle OEF. Don't forget that because the distance from B to C is 5, it means that the distance from E to F is also 5. Now, OV is the height of the triangle, and the height has been already calculated. It has already been calculated. We have 3.54. Now, the angle between the faces OAB and the OCD is the angle theta as shown in the pyramid. But we need to divide the angle into 2 so we can find the beta. After calculating for the beta, we multiply the beta by 2, and that will give us the angle theta. So when we consider the angle beta, we can see that 2.5 is opposite and 3.54 is adjacent. Now, considering the triangle OVF, the angle is beta, and 2.5 is opposite and 3.54 is adjacent. So use the ratio tan. So tan beta is equal to 2.5 divided by 3.54, and this is equal to 0.7062. Now, because we are solving for beta, we have to take the tan inverse of both sides. And when you take the tan inverse of the left hand side, you are left with beta. And taking the tan inverse of the right hand side, we have 35.2 degrees. Now, you know that the angle theta is equal to 2 times beta. So when you multiply 2 by beta, we have the angle theta. And so theta will be equal to 2 times 35.2 degrees. And this is equal to 70.4 degrees. So the angle theta is equal to 70.4 degrees. Now let's consider this example. PQRV is a right pyramid with a base PQR, which is an equilateral triangle of sides 18 centimeters, which is an equilateral triangle. So the base is an equilateral triangle. It means that all the sides are equal. So if one side is 18, then the other sides are also 18. Each sloping edge of the pyramid is of length 13 centimeters. So we are given the sloping length of the pyramid to be 13 centimeters. G is the center of symmetry. G is the center of symmetry of triangle PQR. Now, given that the distance PQ is 10.4 centimeters, calculate. Given that the distance from P to Q is 10.4 centimeters, calculate I, the angle between PV and the base to the nearest degree. II, the height VG of the pyramid, correct to 1 decimal place. III, the volume of the pyramid in centimeters cube, correct to the nearest centimeters. Now let's look at the solution. We are given the pyramid with PQR to be the base. That is the equilateral triangle. So the distance from P to R is 18 centimeters. The distance from R to Q will also be 18 centimeters. And the distance from P to Q will also be 18 centimeters because it's an equilateral triangle. Now we are given the distance from P to the center of the base, that is G, to be 10.4 from the question. And we are given the distance, the slant edges, to be 13 centimeters. So VP is 13 centimeters. VR is 13 centimeters. And VQ is also 13 centimeters. Now, we are supposed to find the angle between PV, that is this slant edge, and the base. The angle between the slant edge VP or PV and the base. This is the angle theta as shown. Now, so we consider the triangle VPG. So we have triangle VPG. The distance from V to P is 13 centimeters. The distance from P to G from the question is 10.4 centimeters. And we are calculating for the angle theta. Now let's look at the two sides given. We know the adjacent side and we also know the hypotenuse side. That means we use the ratio cos. Now let's proceed. Because we are given the adjacent and the hypotenuse, we use cos theta, and cos theta is adjacent. That is PG over hypotenuse, that is PV. Now PG is 10.4 and PV equals 13. Now 10.4 divided by 13 is equal to 0.8. So it means that cos theta is equal to 0.8. Because we are solving for theta, you have to take the cos inverse of both sides. And in doing that, we have theta on the left hand side equals cos inverse of 0.8. And the answer is 36.9. The answer is 36.9. So to the nearest degree, the angle theta, that is the angle between PV and the base, is 37 degrees. Now, how do we find the height of the pyramid? We consider triangle VPG. VP is the slant edge, 13 is given in the question. The distance from P to G has also been given. And we are calculating the height. And this is a right angle triangle with a 90 degrees angle at G. That means that we can use the Pythagoras theorem, which says that 13 square equals 10.4 square plus VG square. So 13 square equals 10.4 square plus VG square. Now 13 points, we group the numbers or the squares on the left hand side. So 10.4 square becomes minus 10.4 square on the left hand side is equal to VG square. Now 13 square is 169 and 10.4 square is 108.16, and this is equal to VG square. Now 169 minus 108.16 is equal to 60.84, and this is equal to VG square. Now how do you find VG? Take note that the distance from V to G is the same as the height of the pyramid. So finding VG, we need to take the square root of both sides. And when we take the square root of VG square, we have VG. And when we take the square root of 60.84, we have 7.8 centimeters. So the distance from V to G, that is the height of the pyramid, is equal to 7.8 centimeters. Now volume of the pyramid is 1/3 times the base area times the height. We just calculated the height and we had 7.8 centimeters. It means that our height is known. So if you know our base area, we can now find the volume of the pyramid. How do we find the area of the base? We have to consider the base, and the base is the equilateral triangle PQR with the side 18 centimeters. So let's look at how best we can find the area of the equilateral triangle, that is the base of the pyramid. Now, considering the equilateral triangle, we draw a straight line from Q to O. What we are going to do is we are searching for the height. When the height is known, we can find the area, because the area of the triangle is half the base times the height. The area of the triangle is half the base times the height. So how do you find the height? Now that you have divided the triangle into two halves, we consider any of the triangles, either QPO or QOR. Now considering triangle QPO, using the Pythagoras theorem, 18 square is equal to 9 square plus 8 square. And so 9 square becomes minus 9 square on the left hand side. And we have 18 square minus 9 square to be 243. And this is equal to 8 square. How do you find h? We take the square root of both sides. When we take the square root of h square, we have h. And when we take the square root of 243, we have 15.59 centimeters. That means that the height of the equilateral triangle, that is the base of the pyramid. Take note that this height is not equal to the height of the pyramid. This height is the height of the equilateral triangle, that is the base. So the height is 15.59 centimeters. And so now the area of the equilateral triangle will now be half the base. That's the distance from P to R is 18 times the height, 15.59. And the area is equal to 140.3 centimeters square. The area is equal to 140.3 centimeters square. So the volume of the pyramid will now be 1/3 times the base area times the height. Now we've calculated the base area and we had 140.3 centimeters cube. Take note that the height of the pyramid itself has already been calculated and we had 7.8 centimeters. So the volume will now be 1/3 times the base area, that is 140.3, times the height of the pyramid, that is 7.8. And we have 364.78 centimeters cube. So to the nearest centimeter, it is V equals 365 centimeters cube. Now let's consider prisms. Prisms are solids with uniform cross section. Prisms are solids with uniform cross section. And these are examples. You have a cylinder in which the cross section is a circle as shown. And we also have a triangular prism. The cross section is a triangle, also as shown. Now, if you try to cut across the cylinder as shown, these are the three shapes you are going to have. And take note that the cross section is uniform. It is the same cross section. It's the same cross section. That is what we call a prism. So prisms are solid with uniform cross section. With uniform cross section. Now, when you consider a triangular prism, when you cut across as shown, these are the two prisms you have, and we can see that the cross section is the same. The cross section is the same. So this is a triangular prism. Now the surface area is equal to the sum of the area of each face. The surface area equals the sum of the area of each face. The volume of a prism is equal to the area of the cross section times the length. So take note of these relations. Now let's consider this example. Assuming we are given this triangular prism. The triangle is an equilateral triangle because we can see that all the sides are equal. We are given the length of the prism. Now let's calculate the volume of the prism and B, the surface area. Let's look at how best we can calculate the volume of the prism and the surface area. The volume of the prism is equal to area of cross section times the length. Area of the cross section times the length. The length equals 16 as shown. But the area of the cross section is the shaded portion, is the shaded section. That's the triangle. So if you are finding the area of the cross section, it means that we have to find the area of this equilateral triangle. And now, how do we find the area of that equilateral triangle? Area is half the base times the height. So half the base, and the base is 5 times the height. So we need to find the height. Now we consider triangle CAD and use Pythagoras theorem, which says that 5 square is equal to 2.5 square plus h square. So 5 square is equal to 2.5 square plus h square. Now 2.5 square on the left hand side becomes minus 2.5 square, and this is equal to h square. Now we have 25 minus 6.25 is equal to h square. When you subtract 6.25 from 25, the result is 18.75. And it means that 18.75 is equal to h square. Take note that we are solving for h, so we need to take the square root of both sides. Now when we take the square root of h square, we have h. When we take the square root of 18.75, we have h is equal to 4.33 centimeters. That means that the height of the triangular section is 4.33 centimeters. Now that we've calculated for the height, we can now find the area, because area equals half the base, and the base is 5. That is the distance from A to B is 5 times the height, and the height is now 4.33. So the area is equal to half times the base, that is 5 times the height, 4.33, and the answer is 10.825 centimeters square. So the area is equal to 10.825 centimeters square. Now let's find the volume. The volume is equal to area of cross section. Now we've calculated the area, and we have 10.825 times the length of the prism is 16. So when you multiply 10.825 by 16, we have 173.2 centimeters cube. That is the volume. That is the volume of the triangular prism that was given in the question. Now let's look at how we can find the surface area of the triangular prism. And the surface area is equal to the sum of the area of each face. It's equal to the sum of the area of each face. Now we first consider the triangular faces. When you consider the triangular prism, the triangular faces are 2. As you can see, the shaded portions are the triangular faces. So we have one in front and one at the back. So because when we calculated the area of the triangular section, we have 10.825. That means that if you want to find the area of the triangular faces, you multiply the area you had for one by 2, because you have 2 triangular faces as shown. So the area will be equal to 21.65 centimeters square. Now the area of the rectangular faces. The rectangular faces are also 3. So how do you find the area of a rectangle? It's length times breadth. That is 16. That's the length of the rectangle times the breadth. That is 5. That's how come we have 16 times 5. Why are we multiplying the answer by 3? It is because the rectangular faces are 3. The first one is the shaded portion. This is the second one. And this is the third one. And they are all the same because the triangular portion is an equilateral triangle. The cross section is an equilateral triangle. So now when you multiply 16 by 8, that is the length by the breadth, we have 80. We multiply by 3 because we have 3 rectangular faces. So 3 times 80 is giving us 240. So the area is equal to 240 centimeters square. So the area is equal to 240 centimeters square. So the surface area, which is equal to the sum of area of each face. Now you've gotten the area of the triangular faces, and you've now gotten the area of the rectangular faces. So when we sum the two, we have 21.65 centimeters cube plus 240 centimeters cube. And the answer is 261.65 centimeters cube. Now, let's take note of this question. Assuming we are given this solid cuboid, the length of this solid cuboid is 11. The breadth is 4 centimeters and the height is 3 centimeters. Now, let's do this analysis. Assuming that this is a metallic cuboid of length 11 centimeters, breadth 4 centimeters, and height 3 centimeters. This metallic cuboid is to be melted to form the shape as shown. And this is a cylindrical conical shape, a cone together with a cylinder. So assuming that this metallic cuboid is melted and the molten metal is molded to form this shape. Now, the height of the cone is 4x centimeters. The base radius is 3 centimeters. And the height of the cylinder is x centimeters. That means that if you know the height of the cylinder, you can multiply the height of the cylinder by 4, and that will give you the height of the cone. Now we are asked to calculate the height of the cone, and that is 4x. Then the volume of the cylinder. Then the volume of the cylinder. Now let's proceed. Take note that we are calculating for the height of the cone. The height of the cone. And the height of the cone is 4x. But because the x is not known, we have to calculate for the x. How do we even calculate for the x? Please look at this. This is the metallic cuboid. The volume of this cuboid is the length times the breadth times the height. So we have 11 times 4 times 3. That is how come we have 11 times 4 times 3. And this is equal to 132 centimeters cube. So this is the volume of the cuboid. Now take note that it is this cuboid that we melted to form this shape. That is a cylinder together with the cone. So the volume of the new solid will be equal to the volume of the cone plus the volume of the cylinder, because this is a conical cylindrical shape. So the volume of this new solid will be equal to the volume of the cone alone plus the volume of the cylinder. Now, volume of the cuboid is equal to 11 times 4 times 3, and we had 132 centimeters cube. And we are saying that the volume of the new solid is equal to volume of the cone plus the volume of the cylinder. Now, the volume of the new solid will be equal to the volume of the cuboid, assuming that all the molten metal was used to form the new solid. That means that none was wasted. It means that the volume of the cuboid will be equal to the volume of the new solid. So volume of the new solid will be equal to the volume of the cuboid. That is 132. So we have 132 centimeters cube is equal to the volume of the cone plus the volume of the cylinder. So we have 132 is equal to the volume of the cone is 1/3 times the base area. And because the base is a circle, it's pi r squared times the height. plus the volume of the cylinder equals pi r square h. Now we proceed. 132 centimeters cube will be equal to the volume of the cone plus the volume of the cylinder. And the volume of the cone is 1/3 times pi r square times h. Plus volume of the cylinder will be pi r square h. Now 132 is equal to 1/3 times pi is a constant, that is 22/7, times the base radius is 3 from the diagram. So we have 3 squared times the height of the cone is 4x, plus the volume of the cylinder is pi r square h. So the pi is the constant, 22/7, times r is the base radius, that is the radius of the cylinder. It is equal to the base radius of the cone. It's the same 3. So we have 3 squared times the height of the cylinder is x. So we multiply by x. Now we have 132 is equal to 1/3 times 22/7 times 3 squared, that is 9, times 4x will give us 37.71x, plus 22/7 times 3 squared times x will give us 28.29x. And now 37.71x plus 28.29x will be equal to 66x. And so 132 is equal to 66x. Now if 132 is equal to 66x, how do we solve for x? We divide the right hand side by 66 as shown. Then we divide the left hand side also by 66 as shown. Now 66 cancels 66 and we are left with x. Or 66 goes into 66 once. 1 times x is x. And 66 goes into 132 2 times. That means that the value of x is equal to 2. So x is equal to 2. Take note that the height of the cylinder was x. So the height, if you want to find the height of the cone is 4x. That means we have to multiply 4 by the value we had for x, that is 2. And so 4 times 2 is equal to 8 centimeters. So the height of the cone is equal to 8 centimeters. The height of the cone is equal to 8 centimeters. Now, volume of the cylinder. The formula for finding the volume of the cylinder is pi r square h. Pi is the constant, 22/7. R is the radius of the base, that is 3 centimeters. And h has been calculated to be 2 centimeters. So the volume will now be 22/7 times 3 squared times 2. And the volume is equal to 56.57 centimeters cube. This is the end of our presentation.